All right, welcome back, everyone. Mr. Anderson here again. Feeling a lot better because I just finished recording 3.1c and it worked. And so I feel a lot better. So hopefully this one will work as well. By the way, I didn't even mention this in the last one, but look what I'm wearing today. Got my Razorback shirt on, so we're all ready to go. All right, we're in section 3.2 today. And we're going to talk about solving systems of inequalities, and we do that by graphing. Okay, so that's the only way that we solve these is by graphing. And so it shouldn't be too difficult or too long today. So let's go. Let's take a look at the objectives first of all. And we're going to try to solve systems of inequalities by graphing, number one. Number two, we're going to try to determine the coordinates of the vertices of a region formed by the graph of a system of inequalities. Okay, all that means is we're going to have several inequalities that we're going to graph, and we're going to do the shading, and the shading is going to make a shape. I think on my example today it's going to be a triangle, and then all we do is see the vertices as just the corners of the triangle. So we're just going to find the coordinates, the x and y coordinates for the corners of that triangle is basically what we're going to do. All right, so here are our steps to solve systems of inequalities. Number one, we want to get the inequality in slope-intercept form. When in doubt, get something in slope-intercept form, right? Number two, we're going to graph it and we're going to shade the correct area. Okay, so that's just one of the inequalities, and we're going to do that just like we would have done before. And then we're going to do the other one. We're going to do both of them, and then we're going to see where the two shaded parts overlap. Okay, so that's the only thing different is we're going to do two on the same coordinate plane and just see where the shaded parts overlap. All right, so let's get started. First of all, we've got a couple of inequalities here, and I am going to graph them. All right, so first of all, if we take a look at these are, whoops, I think I messed up there. These are both in y equals mx plus b form already, so they're ready to graph. All right, so where do I begin on the first one? Where do I begin? We begin at -3. And remember, that's the y-intercept. And so where's y? Here's y. So we go to 1 to -3 on y and put a dot. And then what's its slope? Remember, the slope is this number here. That's the slope. And remember, whenever it's just a regular number like that, think of it as over 1. So it's going to be 2 over 1. So here, I'm going to go up 2 and over 1. Up 2 and over 1. Do a few of those. And then down to 1 to the left. All right. Annalee, is this a solid or a dotted line? It's a solid line because there's an equal sign. Good. And so I'm going to draw a solid line here. And then greater than is above. Now I'm not going to really shade this in darkly yet because I have to see where the other one's going to go. But I'm just going to make a few lines here to show myself that it's going to shade above. Okay? So that's the first one. All right, let's change colors here. And let's go down to, all right, Jack, what color do you want? Really? Orange? Okay, orange. Okay. That's a little weird. Where do we begin? We begin with 2. So we go to 2 on the y-intercept. Orange. Weird. Okay. And then what's the slope here? Now the slope, it's just a negative x. So remember, if it's just a negative in front, that counts as a -1. And remember, just like here with the 2, if it's just a number, not a fraction, it counts as that number over a positive 1. So from from our y-intercept here, we're going to go down 1 and 1 to the right. Down 1, 1 to the right. We're going to do a few of those. Or we could go up 1 and 1 to the left. All right, is it a solid or dotted line? There is no equal sign, so it is dotted. Okay, that's going to try to turn here to do this a little better. So there's our dotted line. And since it's less than means we're going to shade below the orange line. All right, so now you can see where the blue and where the orange get shaded. And so what I'll do here really quickly is I'm just going to switch this over to black. And so black is where they both overlap. So where do they overlap? Here's where the orange is. Here's where the blue is. So this part right over here is where they overlap. And so that's where I'm going to shade it in really darkly there. And that's my solution. So what that means is, it means that all of the points that are in this shaded area over here, every single one of those points, the combinations of x and y, when you put them in to these inequalities, it will make both of them work at the same time. If you pick points from this part up here and plug it in, it'll make the blue, the first one, true, but not the orange one. If you pick points down here, it'll make the orange inequality true, but not the blue one. And if you pick points from out here, it won't make either one of those true. Okay? So the black is where our solutions are. All right, example 2. All right, again, we've got two inequalities. Let's try to graph them. I'm going to go back to red, or whatever that is, kind of a brick color. All right, first one, is it in y equals mx plus b form already? It sure is. So where do we begin? We begin at 5. So 1, 2, 3, 4, 5. And its slope, there's no number in front, so it counts as 1. And remember, it's like 1 over 1. So we're going to go up 1 over 1, or down 1 and 1 to the left. So it's going to look like this. Equal sign means solid line. All right, second one. All right, color. Oh, how about green? Now this is not in y equals mx plus b, is it? We have to get it there. So what's the first step? What do you think we would do here? Keaton, what would we do? Subtract x, good. Okay? Now, notice when we subtract x, we still have a negative left in front of the y, so we've got a negative y greater than negative x plus 4. How do we get rid of the negative? Divide by negative 1, which switches all the signs, and hopefully at this point an alarm bell is ringing in your head that says, oh, we're dividing by negative. We also have to flip the inequality sign, so instead of greater than, it's going to be less than x minus 4. So that's what we're going to use to graph. So we begin at negative 4. 1, 2, 3, 4. Its slope is also 1, or 1 over 1. So it's going to look something like this. And it's going to be a dotted line because there's no equal sign there. So make this a dotted line. And, oh, I forgot to do the shading on these, but if you look, this one is y is less than. It's going to shade down here. And the first one, which I should have finished before I changed colors, it was greater than, so it would shade up here. And so you go, hey, wait a minute. It doesn't overlap anywhere. The shading parts don't overlap. So, just like before, think about this. Remember, if the solution is where they overlap and they don't overlap, What do you think it is? No solution. Good. Now, here's one thing watch out for. Just because you get two inequalities that are parallel lines, it doesn't automatically mean it's no solution. Okay, like this one was a no solution. But it doesn't automatically mean that, because you have to pay attention to the shading. It's only no solution if the top one gets shaded up and the bottom one gets shaded down like we did here. But if it was a little bit different, if, like for example, let's say if the top one was shaded down, let's say it was shaded this way, and that bottom one was shaded up, guess what? They would overlap then. They would overlap in the middle, and you'd shade in everything in the middle. Or if they were both shaded below, the red one was shaded below and the green one was shaded below, they wouldn't overlap in the middle, but if you kept going, they would overlap on the bottom. Or if they were both shaded up, they wouldn't overlap down here in the middle, but if you kept going, they would get shaded above. So when it's equations, parallel lines always mean no solution. But when they're inequalities, sometimes it's a no solution, and sometimes there is a solution. So you got to watch the shading to make sure that the shading tells you what to do. Okay, so don't just jump to the conclusion that it's no solution. Be careful. All right? All right, last one. This is our fun one here with the three. We've got three of them here, and as you can see up here, it tells us that it's going to make a triangle, and we're going to try to find the corners or the vertices of that triangle. All right, so let's just kind of go through our steps here. Since I already have red, we'll start with red. I'm going to get y by itself, so I'm going to go minus 2x, minus 2x. Notice I still have a negative in front of the y, so I have a negative y greater than or equal to negative 2x minus 1. Divide by a negative 1. Alarm bells should be going off in your head saying, oh, we just divided by a negative. Flip it to less than or equal to 2x plus 1. All right, so that's our first one we're going to graph. Start at 1. Its slope is 2 over 1. So up 2 over 1, up 1, 2 over 1. We can also go down 2 and 1 to the left a few times. So something like that. And all of these are equal to, so we can just all draw solid lines on this kind. And since it's less than, we're going to shade below. All right, that's the first one. Next, let's go to blue. This one, just all we have to do is minus x. That one's not too bad. So we have y is less than or equal to negative x plus 4. Okay, so that's the next one we're going to graph. 1, 2, 3, 4. We're going to start right here. And then we're going to go down 1 over 1, down 1 over 1. It's going to look something like this. Ugh, how am I going to draw that line very well there? Okay. That's not bad. And that one is also less than, so less than the blue is going to go below it. Okay, so far that's what we've got. We got one more to do. And let's go to, how about green? So I'm going to go minus x, 4y is greater than or equal to negative x plus 4, and then divide by 4. So you're going to have y is greater than or equal to, remember this is a negative 1, so this counts as a negative 1 over 4, or a negative 1/4 x. 4 over 4 is 1. So we're going to use that equation. We're going to begin at 1. And then we're going to go down 1, and 1, 2, 3, 4 over. or up 1 and 1, 2, 3, 4. So you can kind of see the line there. It's going to go something like this, through there, and through there. And this one says that y is greater, so it's going to be above. So I think you can see here that below the blue, below the red, and above the green is going to be that's the triangle that it makes right there. So all that we have to do then is tell what are the vertices, or what are the x and y coordinates at the corners of the triangle. So our first corner, where's my thing here? That right there is 1. So 1 for x, and then 1, 2, 3 for y. So we have 1, 3. The second one here we've got is right here. So that's 0 for x and 1 for y. So 0, 1. And then the other one is right here. That's 1, 2, 3, 4 for x and 0 for y. So 4, 0. And so our 3 vertices, or the corners of that triangle, are 1, 3, 0, 1, and 4, 0. Okay? That is it for this lesson. Thanks for stopping by, and I'll see you next time. Take care. Bye.